All right, guys, so on this worksheet, we want to practice vertex form. And not only that, if you notice, a lot of the A values, the majority of the A values are not 1. So I want you to practice modifying your pattern or using an XY table, whatever you feel more comfortable with. So if we go to number 1 right here, if you want to think of this as standard form, you can, right? Standard form is ax squared plus bx plus c. And there is no bx term, which means that b is 0, and there is no c, which means that c is 0. And if you did use the formula negative b over 2 times a, that'd be negative 0 over 2 times 4, and 0 divided by 8 is still 0, so the vertex x value is 0. And if you already know your vertex x value is 0, you plug it in to find your y value, which is also going to be 0. Or, instead of thinking of it as standard form, you could think of it in vertex form. And in case you forgot what vertex form is, it's y equals a parentheses x minus h, close parentheses, squared plus k. And what we need is the parentheses. So I'm going to put parentheses around the x. That way. So if you do see it with the parentheses around the x, you could think what value is in there being subtracted from x. Well, there is no value, so your h is 0. And your k value at the very end that's being added or subtracted is also not there, which means 0 also. So the vertex is definitely 0, 0. So it doesn't matter if you look at it in standard form or vertex form. Either way, the vertex is 0, 0. And now for the rest. Let's first graph the vertex, the most important point, 0, 0. After that, we draw the axis of symmetry, which happens to be the y-axis itself. And that equation of the axis of symmetry is x equals the x value of your vertex, which is 0, right? So check this out, guys. You're going to get 1 point for the vertex. And actually, on the test Friday, quiz Friday, I want you to, it's going to have this same exact setup. I want you to box in the vertex, box in your axis of symmetry, and you're going to be getting 1 point for each of these that you get correct, all right? Now, it comes time to find more coordinates. So you either need to make an XY table, which is pretty easy to do, or you could use a pattern or table. I'm going to do both so you guys could choose whichever one you feel more comfortable with. So if you want to go for an XY table, you need to pick values on the same side of your axis of symmetry. So if you do pick the number 1, right? The axis of symmetry is at 0. Pick 1, and let's see what we get. Plug in 1 right there. What's 1 squared? 1. And then 1 times 4? 4. So when you plug in a 1, you get out of 4, and that is a coordinate. Let's graph the coordinate. 1 on the x, 1, 2, 3, 4 on the y. There it is. Now what if I plugged in a 2? 2 squared is 4, and then 4 times 4, 16. So we know that that's way off the graph, right? 2 16's way up here somewhere, right? So we don't need to actually plot it, but just keep in mind that it is somewhere up here. So map the blue dot over to the other side of your axis of symmetry and draw your parabola. Now keep in mind, you don't want to go this way. That's wrong, right? You want to remember that your other dot is way up here, right? So make sure you kind of point in that direction, like that. Same thing with the other side, like that. So it is a very narrow parabola. Why is it narrow? Because the a value is 4. The further away you get from 0, the narrower it gets, the skinnier it gets. The closer you get to 0, the wider it gets. Anyway, that was using an XY table. I believe everybody understands how to use an XY table, right? You just plug in a number, get out an answer. And you know what? Using an XY table gives you the true understanding of what a graph is. What is a graph? A graph is a representation of all the solutions that work for an equation, right? The 1 for the x gives you the 4 for a y. That'll be a true statement. The 2 for the x, when you do the math, it'll give you 16 for y. That's a true statement. So an XY table really does provide you with all the solutions that exist to an equation. But if you didn't want to use an XY table, you could use the pattern. The pattern that we have memorized is 1, 1, 2, 4, 3, 9. However, because the a value is not 1, we can't leave the pattern like this. this pattern has to be modified according to this new a value of 4. So how do we modify it? The second numbers, the outputs of your pattern, have to be modified by 4. So how do I change the second number on the 1, 1? Instead of 1, 1, it's going to be 1, 4, because 1 times 4 is 4. Instead of 2, 4, it's going to be 2 what? 2, 16. Now, why is that? Because I need to modify this 4 with this other 4. So 4 times 4 is 16. Instead of 3, 9, what's the 9 going to change to? 9 and 4, what do I get? 9 times 4? 36. So instead of 3, 9, it's 336, which is obviously way off the graph. Okay? So check out how the pattern works. Instead of 1, 1, it's going to be 1, 4. Instead of 2, 4, it's going to be 2, 16. Instead of 3, 9, it's going to be 3, 36. So from the vertex, I want to go 1 over and 4 up because it says 1, 4. And it does get me there. 1 over, 4 up gets me right there. Now if I go to the next one, 2, 16, I go 2 over, 16 up. That'll get me to the next one way off the graph. So it's up to you whether you like the pattern or whether you like using an input-output table. You get to choose. But right here, it says pattern or table. Whatever you use, please circle it because that's going to be another point when we grade it. Domain. The domain is what? X equals all real numbers. Circle that or box that in. You get another point for that. The range is y is what? Greater than or equal to or less than or equal to?
Greater than.
It depends if it opens up or down. It opens up, which means greater than or equal to. So you're going to put greater than or equal to. Yes, the y value of your vertex, which is 0. Box that in. You get another point for that. How about the x-intercept? Where does this parabola cross the x-axis? 0. Does it cross at 4? Does it cross at -1? Where does it cross? It crosses at 0. It touches at 0. Sometimes your parabola crosses at 2 locations. Sometimes it only crosses at 1 location. Sometimes your parabola is up here and it doesn't cross at all. You would say none if that were the case. It does not cross the x-axis. So the x-intercept in this case is 0. And we're going to box that in. You get another point for that. How about the y-intercept?
0.
It's also 0. Box that in. You get another point for that. And that's about it. Easy peasy, right?
So you get points for.
You get 1 point for each of those that you answer. And of course, a couple of points for graphing it correctly, if you don't graph it correctly. But to be honest with you, you could answer probably the majority of these without actually graphing it, if you really wanted to. Like, let me show you. Number 2 right here. What is the vertex? If we think about vertex form now, vertex form has parentheses around the x and the square on the outside with the a value of -3 in front of the outside of the parentheses. So what's the vertex right there? Remember h and k. What is h inside parentheses? Now, okay guys, does it say x minus 1 in here? 0, right? Okay, so 0 and 2 is the vertex. Okay, now check this out. What is the axis of symmetry, even without drawing it? It's going to be x equals the x value of your vertex. How about the pattern that you're going to use? Well, if you're going to use a pattern or the table, the pattern would be instead of 1, 1, 2, 4, 3, 9, it's going to be multiplying the second numbers on your pattern by the new a value, which happens to be 3. Now, it is -3, but I just want you to multiply by 3. Why is that? Because you already know that the negative represents you're going to be going down instead of up. So instead of 1, 1, it's going to be 1, 3. Instead of 2, 4, it's going to be 2, 12. And that's already going to be off the graph anyway. Instead of 3, 9, it's going to be 3, 27. So there's your pattern, 1, 3, 2, 12, 327. But you could always go back to an XY table and just plug in the number 1, right? So like, let's say you wanted to use an XY table. You could plug in 1. So if you plug in 1 right there, 1 squared is 1. 1 times -3 is -3. -3 plus 2 is -1. So you could actually just use an XY table and get the input 1 and the output -1. Or you could plug in a 2, and if you plug in a 2 right there, 2 squared is 4. 4 times negative 3 is negative 12. Negative 12 plus 2 is negative 10. So I did both, the XY table and the modified pattern. It is totally up to you with whatever you want to do. So, like I said, I'm answering all these extra points that you're going to get without even graphing, right? Like the domain, I already know the answer to the domain. What's that? All real numbers. So x equals all real numbers. You get another point for that. The range, it's going to be y. Is it going to be greater than or equal to or less than or equal to? Less than or equal to, because the a value is negative, which means it's going down. So I already know it's less than or equal to. And I'm not even looking at the graph here because we haven't even graphed it yet, but we know it's going to be less than or equal to the y value of your vertex, which is 2. So you guys see how we're getting all these points even without the graph? The x-intercept, okay, I don't know where it crosses the x-axis. I needed the graph for that. The y-intercept, I don't see it, but I could find the y-intercept by setting x equal to 0 and solving, right? So check that out. If I set x equal to 0, 0 squared 0, 3 times 0 is 0, what's my output going to be? It's going to be 2. So the y-intercept is actually 2. So I answered all of these, except for the x-intercepts, without even graphing. Okay. Anyway, let's actually graph now. So 0, 2. 0, 2 is right here. Axis of symmetry is right through it. We said it's the x equals 0 equation right there. We need more coordinates. Did you guys want to go with the xy table right here? Or did you want to use the pattern 1, 3, 2, 12? Pattern? Okay. Either way, check this out, guys. I want to use the table first, the 1, negative 1. So if I go 1 on the x, negative 1 on the y, I want to get a dot right here. And let's all put that dot right there. So if you use the xy table, you're going to get to that dot. Or if you use the pattern 1, 3, but you know it's opening down. Why is it opening down? Because the a value is negative. So you're going to go 1, 3, and you're going to get to that point anyway. So it doesn't matter if you use the pattern or the table, whatever you feel more comfortable with, go for it. And of course, you map it over to the other side. So we're going to map it over to this side. And that is about it, guys, because when you try the next part of the pattern, the 2, 12, check it out. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I guess I want to draw it here. 12 is way down here. And I am going to map it over to the other side over here. Now, it's not necessary, but it is good to have those points. So when you draw your parabola that's pretty narrow, you actually point to those guys. Right? You're pointing to these guys. Because a lot of people, they draw this and then they end up going this way for some reason. Right? Make sure they point to those other coordinates. So it's up to you if you want to use the XY table or the pattern. I don't know, pick one, 5 or 6. Or should we just keep going, 3 and 4? 3 is the same as number 1. It's just negative, it just goes down. Let's go for 6. Or should we go for 4 because the a value is half? 4. So right here, what's our vertex? Think about the parentheses being around the x. H and k. What's h? 0. K is negative 3.
And then your
Axis of symmetry, x equals 0, the x value of your vertex, right? Pattern. Do you guys want to use a pattern or you guys want to use a table? Or do you want to do both? So you could just see both. All right, so if you want to say pattern, you're going to have 1, 1, 2, 4, 3, 9, but you got to modify the 1, the 4, and the 9 by multiplying by half, by your a value, which is half. Now, I'm not going to do negative half because I already know that the negative means I'm going down. So I want to take that 1, multiply it by half, and it's going to become 1/2 because half of 1 is 1/2. And what is half of 4? 2. What's half of 9? 4.5, right? Or 4.5. So that's kind of a funky pattern because you're in halfway points. I don't know. You might want to use an XY table. Either way, we're going to be able to graph this. 0, negative 3 is right here. Axis of symmetry is right through it, which is a y-axis in this case. Let's go for the pattern 1, 1/2. Now, This is an a value of -1/2, which means you're going to be going down. So we're going to go 1 over 1 halfway down. All right, check this out. 1 over halfway down is right here. So it's kind of weird, it's funky. So let's put a dot right there at the halfway down point. What's the next pattern? 2 over and 2 down, right? So go back to the vertex, go 2 over and 1, 2 down, and put a dot right there. And the final part of the pattern is not 3, 9, but 3 and 4.5. So if I go back to the vertex 1, 2, 3, and go down 4.5. 1, 2, 3, 4.5. I'll be right there, almost to the edge, but it has to be halfway. You can't put it here, you can't put it there. It has to be halfway. It's 4.5 down. So you end up with this coordinate right there. Let's map those points to the other side. So mirror image, 1 unit away, 1 unit away. It's going to be right here at the halfway point. The other one is right there at a nice coordinate. The other one's down here at the halfway point. Connect your dots, and yes, you end up with a wider parabola than usual. Why is that? Because the a value was 1/2. It's closer to 0. It's -1/2, actually, which means that it's wider than your regular U-shaped curve. The closer it is to 0, the wider it gets. And now we could state everything else. The domain, x equals all real numbers. The range, y is what? Less than or equal to the y value of your vertex. -3. The y value of your vertex is -3. How about the x-intercept values? None. It does not cross the x-axis. How about the y-intercept value? I mean, you could actually see it right there. Or if you want, you could plug in 0 for x and do the math, and you get the c value -3. So the y-intercept is -3. So you get 1 point for each of these. Please box them in. Yeah, I would like to see it boxed in just in case you have other work out here. I don't get confused, right, when I'm checking it. Let's do number 6. What's the vertex? -5, -3. What's the axis of symmetry? X equals -5, right? The x value of your vertex. Let's graph -5, -3. Put a dot right there. Let's draw that axis of symmetry at -5. Now, what pattern or table are we going to use? Do we want to use a pattern? 1, 1, 2, 4, 3, 9 and modify it? Or do we want to use an XY table where I plug in a number, get out an answer? Let's do both, Salgado. All right, let's do both. So check this out. If I go for an XY table, I need to plug in some numbers that are close to my x value of -5. So give me some numbers that are close to -5. What numbers are close to -5? Come on, guys. Even closer. What's closer to -5? -4 and -3. Those are pretty close. I mean, -2 is close, but it's a little bit further away, right? Look, if you guys say -2, let me show you what happens when I plug in -2. When I plug in -2, -2 plus 5 is 3. 3 squared is 9. 9 times -2 is -18. -18 minus 3 is -21. So that coordinate's way off the graph. So you want values that are close. So let's try a -4. Check it out. -4 plus 5 is 1. 1 squared is 1. 1 times -2 is -2. -2 minus 3 is -5. So the coordinate -4, -5 is on this graph, so that's great. Let's graph -4, -5, and let's put a dot right there. Here it is. Let's try -3. If I plug in -3, check it out, guys. -3 plus 5. -3 plus 5 is 2. 2 squared is 4. 4 times -2 is -8. -8 minus 3 is -11. So when I plug in a -3, I get out a -11, and that's off the graph, right? if I try to graph negative 3, negative 11, it would be negative 1, 2, 3, and negative 8, 9, 10, 11. It'd probably be over here. I'll put the dot there just so you could see it. But we're definitely way off this graph. It's unnecessary. Let's map the blue dots over to the other side. So you have a dot right here and down here. And when you graph your parabola, just make sure you're pointing at those other dots. So that was the pattern. That was a table. You could have used the pattern. Check it out. Here's the pattern. 1, 1, 2, 4, 3, 9. But we need to modify the second numbers on those patterns by this new a value of 2. So instead of 1, you're going to multiply 1 by 2 times 2. And what do we get? We get 2. Instead of 4, what are we going to get? Times 2, we get 8. Instead of 9, times 2, we get 18. So it's not 1, 1. It's 1, 2. It's not 2, 4. It's 2, 8. It's not 3, 9. It's 3, 18. From the vertex, and of course going down because the a value is negative. So 1 over 2 down, let me show you what happens. From the vertex, 1 over 2 down, that's how you get to that blue dot. If you go to the next pattern, 2, 8, from the vertex, 2 over 8 down, you'll get to that blue dot. So you could use a pattern if you want. You could use the XY table if you want. It's totally up to you. Let's continue with everything else here. Domain, x equals all real numbers. Range, y is what? Less than or equal to the y value of your vertex. What's the y value of your vertex? Negative 3. How about the x-intercepts? Where does it cross the x-axis? None. It does not cross. How about the y-intercept? Where does it cross the y-axis? Ladies and gentlemen, this is an important one. What's the y-intercept? Where does it cross the y-axis? Where does this cross the y-axis? Right here, visually it doesn't, but you need to figure it out. How do you figure it out? You set x equal to 0. So when you set x equal to 0, 0 plus 5 is 5. 5 squared is 25. 25 times negative 2 is negative 50. And negative 50 minus 3 is negative 53. So the y-intercept really is negative 53, guys. So it actually crosses the y-axis at negative 53. That's how you do this stuff. Let's keep practicing. We're going to work on this tomorrow also. Right here on number 3, you could look at it in standard form if you want, or you could look at it in vertex form if you want. Vertex form has parentheses around the x and the squares on the outside. So if you want to, you could put parentheses around that x so it'll look like vertex form. That way you could think of the h value being subtracted inside the parentheses with x, and the k value being added or subtracted out here at the end. So what's being added or subtracted right here with the x?
0.
Nothing. So the vertex x value, the h value is 0. How about the k value? 0. There's nothing being added or subtracted at the very end, so the vertex is 0, 0, and you get a point for that. If you graph 0, 0, be right here at the origin. You draw your axis of symmetry. So the line going right through that vertex value. And the axis of symmetry equation is what?
X equals 0.
X equals the x value of your vertex, which is definitely 0. Now it comes to the pattern here. Pattern or table. So you could use a table or a pattern. Honestly, students have been asking me which one's easier. They're both easy, right? So if you want to use an XY table, go for it. I want to do both so you could compare. I need to plug in two numbers that are on the same side of the axis of symmetry, which is at 0. So two easy numbers that are close to 0 are 1 and 2, and let's do that. If I plug in a 1 right in there, 1 squared is 1, and negative 4 times 1 is negative 4. So you get a coordinate 1, negative 4. If I plug in 2 right in there, 2 squared is 4, and 4 times negative 4 is negative 16. Was that difficult to do? Definitely not. So using an XY table always works. It's not difficult. All you got to do is plug in some numbers, do some math, get out some answers. Or you could either do this, or you could use a pattern 1, 1, 2, 4, 3, 9 if you modify the second numbers on your output according to that new a value, negative 4. But I'm just going to multiply the outputs by 4. See this negative sign, all it tells you is that it's opening down. So all you got to do is modify these three numbers, the 1, the 4, and the 9, by 4. So if you modify it by 4, by 4, by 4, you're going to end up getting a 4, a 16, and a 36. So your new pattern is not 1 over 1 down. It's actually 1 over 4 down. All right, so let's understand that. The new pattern is 1, 4. The new pattern is 2, 16. The new pattern is 3, 36. You're going to go 3 over and 36 down. Obviously, you're not going to use that part of the pattern. That's way off the graph. Anyway, let's graph 0, 0. We already did the axis of symmetry. So it's up to you if you want to use the pattern or the XY table. Whatever you feel more comfortable with, go for it. So if I go 1 on the X, negative 4 on the Y, that'll give me 1, 2, 3, 4. That'll be right here. Put that dot. Map it over to the other side. And that's pretty much it. You're done. I say you're done because if you go to the next part of the pattern or the next coordinate, 2, negative 16, 2, negative 16, you're going to be way off the graph, right? So let's just connect those dots, make a pretty narrow parabola. You might want to go 2, negative 16 just to get an idea of where to put your arrows at, right? So if you go 2, negative, this is negative 8. No, negative 16 is way down there, so yeah. Don't go this way. You know it has to go way down here. So that's a perfect graph right there. Let's answer the rest of the details here. The domain, x equals all real numbers. The range, y is what? It's less than or equal to because it's opening down, so it's less than or equal to. And less than or equal to what? The y value of your vertex. The y value of the vertex is 0. How about the x-intercept value? Where does this graph cross the x-axis? It crosses at 0 also. How about the y-intercept? Where does it cross the y-axis? It actually crosses at 0 also. Interesting, right? We have so many zeros. But anyway, for each one of these, you get a point. The axis of symmetry, I actually want you to box this in on tomorrow's quiz. Pattern or table, whatever you use, box that in. The domain, that's another point. Range, that's another point. Intercept of the x, that's another point. Y-intercept is another point. All those points. And, of course, you get a couple of points for graphing it correctly. Let's take a look at number 5. Number 5 is actually perfectly in vertex form. It also has a different a value. The a value is negative 3. It is opening down. So let's find the vertex. What's the vertex? Think opposite on h, take k for what it is. 2 and negative 4. H, think opposite, and the k, you take it for what it is. So it's positive 2 and it's negative 4. Maybe I shouldn't put a minus in front of the h. Anyway, that's a vertex. Let's graph it. 2 on the x, negative 1, 2, 3, 4. There's my vertex. Let's draw the axis of symmetry right through it. That axis of symmetry is the equation what? What's the equation? X equals the x value of your vertex. That's right. You get a point for that. How about, do you guys want to use an XY table or you want to use a pattern? Or do you want to do both so you could see and choose which one you feel more comfortable with? Both. All right, let's do both. So if I go for an XY table, I need to plug in some numbers that are close to the axis of symmetry x value, or the axis of symmetry. So the axis of symmetry is x equals 2. So give me two numbers that are close to 2. 1 and 0. Both of those are close to 2. They're on the same side, which means that I'll be able to map over those coordinates to the other side. So if I use 1 and 0, let's see what we get. When I plug in 1 right here, 1 take away 2 is negative 1. Negative 1 squared is positive 1. Positive 1 times negative 3 is negative 3, and negative 3 minus 4 is negative 7. So when I plug in a positive 1, I get out a negative 7, and that is a coordinate. 1 on the x, negative 7 on the y, which is down here. Let's put our dot right there. And if I did plug in 0, 0 minus 2 is negative 2. Negative 2 squared is positive 4. Positive 4 times negative 3 is negative 12. Negative 12 minus 4, that's negative 16. 0, negative 16. 0 on the x, negative 16 on the y, that's way off the graph. I'm not even going to worry about that guy, right? I just need to map that blue dot over to the other side. There it is. Connect my dots. Put some arrows. I'm done. That's an ugly parabola. I'm sorry. I should probably make that better. Anyway, the domain, x equals all real numbers. The range, y is what? Greater than or equal to or less than or equal to? Less than or equal to what value? The y value of the vertex, which is -4. How about the x-intercept? Where does it cross the x-axis? It doesn't. So you say none, or does not cross, or not applicable, whatever you want. I'd put none. It just doesn't have any x-intercepts. How about the y-intercept value? We don't know where it crosses the y-axis according to this. Visually, we can't say it, but algebraically, yeah, when you plug in 0, I guess this is important to note. To find the y-intercept, what do? Algebraically, set x equal to 0 and solve. So if I set x equal to 0, I want to have a 0 here. 0 take away 2 is -2. Actually, we already did this on the xy table. When we plugged in 0, we got out a -16. So we know it's going to cross at -16. So the y-intercept, you could either put the coordinate 0, -16, or you could just say the y-intercept is -16. So there's one point, there's another point, there's another point, another point, another point, another point for the axis of symmetry, another point for the vertex, and a couple of points for this actual graph. Each problem is going to be worth a lot of points. I want to end this video now because it's already a ridiculously long video. You have to do both sides by Friday, the day after tomorrow. So make sure you work on this right now in class tonight, and of course finish it up tomorrow if you haven't finished it by tonight.
So is this our test?
Now, okay, this is how our test is going to look, but this worksheet focuses in only on vertex form. There is going to be half that are vertex form, the other half standard form, where you have to use the formula x equals -b over 2a to find the vertex itself. Okay, so don't forget about the standard form, the ax squared plus bx plus c. That's going to come out on the quiz as well.